Hey everybody, it's Mr. Warren here. We're going to talk a little bit about probability and learn a new way of calculating the probability of combined events. So up to now, we've always done combined events with one of these things. This is a possibility diagram. Now, this is a possibility diagram for rolling a six-sided die twice. Now, if you roll a six-sided die, on the first time you roll it, you have, so I'm going to say that this, oops, I don't want green right now. Let me go ahead and get my colors back. I want that purple. There we go. So this top row here represents all the possible outcomes on the first roll. And this column on the side here represents all the possible outcomes on the second roll. And it's really the same for both rolls. You have the numbers 1 through 6. So every square in this 6x6 grid represents a possible outcome from rolling the die twice. For example, this square right here represents rolling a 5 first and a 3 second. I just go to the column and the row and I find out how do I get to this square. So this would be a 5 first and a 3 second. This square right here represents a 3 first and a 5 second. And once you have this possibility diagram filled out, you could answer any question about probability that I asked you. For example, let's start off and let's say, what is the probability that you roll the die twice and you get an even number both times? Okay, so now I do want that green. What I'm going to do is I'm going to go on my possibility diagram and I'm going to put a check everywhere where there's an even number on both rolls. So if I roll a 2 first and I roll a 2 second, well, that's a check. Let's see, I'll keep going down the 2 column. 2, 3, that's no good. 2, 4, those are both even. 2, 6, those are both even. If the next even number on the first roll is a 4, so that's going to be 4 and 2, 4 and 4, 4 and 6, 6 and 2, 6 and 4, 6 and 6. I'm finding all those squares where both numbers that I rolled are even. And let's see, what do I get? I get 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 out of a total of 36 possibilities. Remember, there's 36 possibilities because this is a 6x6 square. And that simplifies to 1 and 4. Okay, so we could answer that question with a possibility diagram. It's a little tedious because you had to go through and count each square. So let's see a different way of doing this. Now, the probability of rolling an even number on the first roll, well, let's see, there's 6 numbers on a 6-sided die. That's the number of possible outcomes. And 3 of those numbers are even, 2, 4, and 6. So the possibility of rolling an even number is 1/2. The probability of rolling an even number on the second roll is the same. The first roll doesn't affect the second roll. So there are 6 numbers, 3 of them are even, and that simplifies to 1/2. Probability is 1/2 for rolling an even number on the second roll. Now, the probability for rolling an even number on the first roll and an even number on the second roll is equal to these probabilities multiplied together. So you take the individual probabilities, the 1/2 and the 1/2, and you multiply them together. And that's what we're going to be doing in your homework and in follow-up assignments. We're going to be finding the probabilities individually without a possibility diagram and multiplying them together. Okay? Let's keep that in mind, and let's look at some of your homework questions. For example, this one. So it says here that the probability that it will rain in a given city in July is 0.1. Now, 0.1 is another way of saying 1/10. So, and we could also say 10%. There's a 10% chance of rain. So the probability of rain on any given day is 1/10. I'll use the fraction. Find the probability that it will not rain on a given day. Well, what does this say? This says that on any given 10 days, well, I guess it doesn't really say that. If there's a 10% chance of rain, that means there's a 90% chance that it doesn't rain. Remember, the probability of something happening and something not happening has to add up to equal 100%. So the probability of rain is 1/10. the probability of it not raining is 9 out of 10, or 90%, or 0.9. So that answers the first question. Find the probability that it will rain on 2 consecutive days. 2 consecutive days means that we're going to multiply our probability of rain by itself. Rain on the first day, that's 1/10. Rain on the second day, that's 1/10. We multiply them together and we get 1 out of 100. Now it does say to write your number as your answer as a decimal, and 1/100th is 0.01. That's the probability that it's going to rain twice in a row. And of course, we could write this as 1%. Find the probability that it will rain on a given day and will not rain the next day. So we're going to multiply the individual probabilities. We're going to multiply the probability that it rains, that's 1 in 10, times the probability that it doesn't rain, that's 9 out of 10. And what do we get? 1 times 9 is 9. 10 times 10 is 100. You get 900ths, which is equal to 0.09, which is the same thing as saying 9%. Okay? So that's how you approach those problems. Now, if you didn't do that, if you did it the way that we talked about, you would have to do a probability diagram that was 10 by 10. So I'd have to come over here, and I would need to have 10, it would look like this. The possibility diagram would look like this. It would be not rain, not rain, not rain, not rain, not rain, not rain, not rain. I don't even have enough boxes. You can see why this is going to be very tedious and very difficult to do events that have a lot of outcomes. It's very tedious to do that with a possibility diagram. So that's why we just multiply the probabilities together. Okay. Let's try the next one. Not that one. Let's do this one. Okay. It says Linda has 2 purple counters, 5 green counters, and 3 yellow counters in a bag. She randomly picks a counter from the bag. Without returning the first counter, she picks another counter. Find the probability that the first counter is green and the second counter is yellow. Now, this is from exercise 5, and this is all about dependent events. So notice that it says here, without returning the first counter. So that means that she takes a counter out and it's no longer possible to pull that counter again. Okay. So let's start with the first one. What is the probability that the first counter is green? There are 5 green counters out of a total of 2 plus 5 plus 3. That's 10. So the probability of pulling a green counter on the first pull is 5 out of 10, or 1/2. And I should actually write this out. So this is 1/2, and this is the probability of pulling green on the first pull. Now, what's the probability of pulling a yellow counter on the second pull? Well, let's see. There's going to be 3 yellow counters. Okay, so the probability, there's going to be 3 yellow counters, but there's not 10 counters anymore because I took one of the green ones out. There used to be 10 counters, now there's 9. Okay, so the first pull affected the number of possible outcomes of the second pull. That's why this is a dependent event. 3 over 9 is equal to 1/3, so the probability of pulling a yellow counter on the second pull is 1/3. And the probability that both of these things happen, that you pull a green first and a yellow counter second, is going to be 1/2 times 1/3. We multiply the individual probabilities together, and that gives us 1/6. And that answers the question. Let's try another one. Find the probability that the first counter is purple and the second counter is green. Speaking of purple. Well, the probability the first counter is purple, so I'm going to write this first. Probability of pulling purple on the first pick. There are 2 purple counters out of 10. That's 1 in 5. The probability of pulling a green counter on the second pull, let's see, how many green counters are there? There's 5. But there's not 10 counters anymore because we took a purple one out. So that means that it's 5 out of 9. And that doesn't simplify. So the probability of pulling a purple and a green is going to be 1/5 times 5/9. The 5's cancel, and I'm left with 1/9. There's a 1 in 9 chance of pulling a purple counter first and a green counter second. Okay, last problem. A board is made up of 16 squares. Each square can fit only 1 coin. Malcolm randomly tosses a coin blindfolded without removing the first. That's key, without removing the first. And you can only fit 1 coin in. So this is a dependent event. He tosses another coin. Given that both coins land in the squares on the board, find the probability that A, the first coin, lands on a white square. Well, let's see. How many white squares are there? Oh, sorry. Let me read the whole thing. The first coin lands on a white square, and the second coin lands on a gray square. The probability of landing on a white square on the first flip, that's why I'm putting that little 1 there. Well, let's see. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 white squares, and there are 16 total squares. So the probability of landing on white in the first place is 3/4. What is the probability of landing on a gray square on the second flip? Well, okay, if I put a coin here, another coin cannot land there. That's what the parameters of the problem state. So I don't have 16 possible places for a coin to land anymore. I have 15 possible places, and I'll go ahead and put that in the denominator right now. That's the number of possibilities on the second flip. There are only 4 gray squares, so the probability of landing on a gray square in the second flip is going to be 4 in 15. Now, the probability that you land on white and then gray is going to be the product. We're going to multiply these two probabilities. So that's going to be 3/4 times 4/15. The 4's cancel, the 3 and the 15 cancel, and we get 1/5. So the probability of landing on the white square first and the gray square second is 1 in 5. Okay, last one. What's the probability both coins land on gray squares? Well, let's see. Probability of landing gray first. How many gray squares are there? There's 4. How many squares are available? 16. So the probability of landing on gray is 1 in 4. The probability of landing on the gray square or a gray square on the second flip, if I have a coin here, it's no longer a possibility. So there are 15 available squares, and only 3 of them are gray now. And that's 1/5. So the probability of landing on a gray square twice, you multiply these together, and you get 1 in 20. And that answers that question. Okay, all of the other problems have very similar setups. So if you have any questions, feel free to ask me on Classroom or send me an email. All right, thanks for watching.